Hello, this is Kabo. In this video I'm going to be talking about mob spawning. I'm going to try to go into as much detail as possible, and to do that I had to go and research the code, so everything in this video is based on my own findings in the Minecraft code, so if you think something's wrong let me know and I'll take a look again. Anyway, almost all of the information that's in this video is going to be up to date on the Minecraft wiki. There are a few discrepancies, but since everything will be covered in this video, don't worry about those. Alright, let's begin. The first thing to mention is that there are two main mob types, hostile and peaceful. This is important because for the game to even try to spawn mobs, it has to have either or both of these mob types able to spawn. Now, for hostile mobs, since they will try to spawn in every tick, the only condition that has to be met is that the difficulty is something that's other than peaceful. And for peaceful mobs, since they'll spawn in any difficulty, the only condition that has to be met is that the current tick is a 1 out of every 400 tick. So basically, once every 20 seconds, peaceful mobs are allowed to spawn. Anyway, if either of those conditions are met, so either type of mob is allowed to spawn, the algorithm will actually start to run and go on to the next step. Okay, so the next step of the algorithm does two things. The first thing it does is to determine a cutoff limit for mob spawning for each type of mob. And the second thing that it does is to determine which chunks will actually allow mob spawning. This first thing, the cutoffs, is determined by counting the chunks in a square of 17 by 17 chunks around each player. So around one player, this would just be 17 times 17. Around two players, it would be 17 times 17 times 2. But if the players are close enough to each other that their squares overlap, then the chunks only get counted once. So it's not 17 by 17 times 2 in those cases. But anyway, the chunks are all counted up, and then this total of counted chunks is divided by 256. This result, after dividing by 256, is taken and then multiplied with the base cutoffs for the mob types, and that multiplied result determines what the limit is for the game. So basically, the more players there are in the game and the further they are away from each other, the more mobs will be allowed to spawn. So the next part, the second part, which is determining which chunks will actually spawn mobs, is done similarly. It takes the list of counted chunks around these 17 by 17 players, and it looks at those and sees which ones are within 15 by 15 chunk squares around the players, and it flags those chunks as being able to spawn. So now the algorithm has a list that it can just loop through. It has a list of chunks, so it can just loop through it and do spawn attempts for those chunks. And just like before, if players have their 15 by 15 squares overlapping, then the chunks will only be counted on the list once. So there are overlaps, there'll be fewer spawn attempts. Alright, so let's take a look at this in the game. If we imagine this brick chunk down here as our player's chunk, then this chessboard pattern represents the 15 by 15 square of chunks around the player. The outer ring here, just one more chunk out in all directions, is representing the 17 by 17 square of chunks. So that's all there is to that. This distance here from one end of the player's chunk to the far end of the 15 by 15 squares is 8 chunks long, so that's 8 times 16, which is 128 meters. The diagonal distance here is 128 squared times 2 square rooted, which is 181 meters. So that just gives you an idea of how far away the game will try to make spawn attempts, despite the fact that outside of 128 meters, mobs will despawn instantly. Alright, so now on to the next part. In this next part, I'll explain the cutoff limits, but first I want to talk about something that's described as the creature type in the code. It's a little bit technical, but I'll try to keep it as easy as possible to understand. Basically, the creature type is another classification that's used by the game, and I guess one way you can think about it is as a type of list that it lists the creatures that fit into a particular type, but at the same time this list also has properties that describes the creatures that are listed in it. So anyway, right now in the game there are 3 creature types: monsters, creatures, and water creatures. And the monster creature type lists all the hostile mobs, creatures is all land-based peaceful mobs, and water creatures is pretty much just squid. So all of these are different creature types. Now, the properties that creature types have that describe the mobs within them are hostility, whether it's hostile or peaceful, material, which I guess you can think of as what the mob breeds, and then the base cutoff limit. So here are the details of each creature type. On each of these signs you can see I have the hostility, material, and base cutoff of each type. This base cutoff is what gets multiplied by the factor we talked about earlier from the 17 by 17 squares. And the value in parentheses next to that base cutoff is the final result after multiplying by that factor in single player. The reason I have that here is because it's constant in single player. In multiplayer, it can actually vary pretty widely. For example, if you have 2 players that are 32 or more chunks from each other, it will result in a cutoff being I think around 158, basically double what it is in single player. Anyway, so let's talk about how this cutoff value actually gets used. So the calculated cutoff value that we have isn't actually the maximum number of mobs. It's actually only what tells the algorithm not to spawn anymore. So the spawning algorithm will loop through the list of spawning chunks for each creature type. So it will go through the list once for monsters, and then go through the list for creatures, and then for water creatures. At the beginning of each of these loops through the chunks for the creature types, it will check this calculated cutoff value against the current number of creatures of that type that are loaded in the world. Now, if there are more than the cutoff, it will skip going through the list of spawning chunks and attempting spawns. But if there aren't, it will just go through all of the chunks in the list. So this sort of goes back to where I said before, it's not the maximum number of mobs. It just tells it where to stop. So it will go through the list, and you can actually have many more mobs spawn than this cutoff value. And of course, if this happens, the next time the algorithm runs, it will probably exceed this cutoff and not spawn, but it's just something to keep in mind. Anyway, let's go to the next part. Okay, now I'm going to get into the interesting part of the algorithm. This is where the spawning actually happens. This is the spawning loop. So if you remember, I said before, the game will loop through all of the chunks that were flagged for spawning. That's basically that 15 by 15 square of chunks around each player. The game will loop through those for each creature type. So once for monsters, it will go through all those chunks, and then once for creatures, and then once for water creatures. And when that happens, it will go through each chunk, and when a particular chunk is selected, it goes through a series of steps that determine how mobs spawn, if they spawn, or where they spawn. And this is how it works. So let's take this chunk as an example. The first step that we're going to look at is a block gets randomly chosen within this chunk. And this first block that gets chosen isn't necessarily where mobs will spawn, but it's pretty important. It's used later on within the computations for this chunk. So for easy reference, let's just call it the initial block. So this initial block gets chosen within the 16 by 16 area of the chunk. And that's from the bottom of the map to the top of the highest segment in the chunk that contains a non-air block. So it's a pretty big range. You might not understand because you don't know what a segment is, so let me explain that. A segment is basically a vertical division of the chunk, and it's just a division that the game code uses to make computation easier. The name segment itself probably just comes from Minecraft Coder Pack. When they deobfuscated the code, they needed something to name it. But that's all it is, just a section in the vertical of the chunk. And these sections, called segments, are 16 blocks tall. And they start at the very bottom, so you've got 0 through 15, that's 16 blocks. That's one segment. And you've got 16 through 31, another 16 blocks. That's another segment. 32 through 47, another segment, and so on, all the way up to the top of the map. So as you can see, it's pretty easy to figure out what segment you're in. You just look at the multiple of 16 that's lower than the block you're in, and that's the segment you're in. And then if you go up 15 blocks, basically go up to the next multiple of 16 and subtract 1, that's the top of your segment. But for builders, there's actually an easier way, and that's this LC value here. So if you look at the debug screen, on the left-hand side, second row from the bottom, you'll see LC. And right now my LC value is 31. This is telling me the top of the highest segment that has a non-error block. So it's exactly the number that we need to know for our build. And as you can see, if I move into another chunk, because we have a different structure height, obviously we're going to have a different highest segment in the block. Now, this marker here is basically what a segment looks like, but it's not actually where the segment is. The top of the segment is actually up here. This is just an example to show you what it looks like. Alright, so let's go up to the segment. You can see my head position is at 31, and if I go up, it's at 32. What this means is I'm moving in between two segments right now. So if this is the top of a segment and the block above is the bottom of a segment, what would happen if I built one block up? Well, if you guess that the LC value will increase, then you're correct. And as you can see, when I place a block there, it does in fact increase, and it increases by 16. That's because, like I said, it's looking at the top of the segment that has the highest non-air block. So now that this segment is the one that has the highest non-air block, rather than looking at the bottom, which is here at 32, it's looking at the top, which is at 47. And that's how that works. Also, you'll notice that when I broke that block, my LC value is still 47. That will be fixed when you restart the map, so don't worry about that. As soon as you restart the map, it will go back to whatever the next lowest block is. So if I were to restart, it would go down to 31. But anyway, that's how the segments work. That's how this first initial block is chosen. Basically, you just find out where your chunk is and then find the LC value, and that's all you need to know for building your mob spawners and stuff like that. Alright, let's go into the next step. So the second step is pretty quick, but it's still important. Basically, it's just looking at the material of the block and the material of whatever the creature type. So the creature type can either have a material of air or water. So what it's looking for here is air or water, depending on the creature type. If it's a monster or a creature, it'll be looking for air. If it's a water creature, it'll be looking for water. If the block here is a material other than those, and it doesn't match the creature type, then it will just skip this chunk and go on to the next one and go through the spawning loop here. This is important because if you don't have spaces where the mobs can spawn, basically if the mob can't breathe in any of this space, then it won't be allowed to spawn at all, and it will just skip this chunk and go on to the next. So that's why the second part is important. Now let's go into the third part. So this third part is probably kind of confusing because it's like a bunch of little steps. It's basically a bunch of little loops. And this is how it works. So we've got our initial block chosen, and packs of mobs get placed around this initial block. What I mean by packs is basically a set of mobs of a certain number. And these packs are what determine how many mobs will spawn and what creatures will spawn. What type of mob will spawn. So one pack could be creepers, and then another pack could be skeletons, and then another pack could be zombies. It's random, so it doesn't really matter. You could have zombies and then creepers. But basically, these packs determine how many mobs and what types. Now, this pack spawn attempts are actually in a loop, and this loop goes 3 times. So you've got up to 3 mob packs that spawn. So you could have up to 3 different mob packs. And inside of these mob pack spawns, you've got a loop of spawning attempts for individual mobs, and that happens 4 times. So the way you could look at it is basically you've got 12 spawning attempts. Now, this doesn't mean, though, that you could just spawn 12 mobs. Even though you have 12 spawning attempts, it doesn't mean you're going to necessarily get 12 individual mobs to spawn. It doesn't work like this. There's actually a limit to the chunk. Now, this limit is based on whatever type of mob is actually being spawned at the time, but in almost all the cases it's going to be 4. There are a couple exceptions to that, which I'll explain later. So since this is going to be 4, you can't have 12 like this. Instead, you really can only have 4. And this is for the chunk. As soon as it hits this limit, we'll go on to the next one. So it doesn't matter if it's 4 in 1 pack like this, or 4 in 2 packs like this, or even 4 in 3 packs. As soon as it reaches this limit, it will go on to the next chunk. Of course, it doesn't have to reach that limit. You could spawn 1 and it would go on to the next chunk. But that's the way it works. Anyway, let's talk about how the selection of blocks and placement of mobs actually works. So we've got our initial block here. What it's going to do for each pack is look at an 11 by 11 square that's centered on that block. So anywhere in this square of 11 by 11, you could have a placement of a mob. So for our first attempt, let's just say we get a placement here. Oh, by the way, this is all in the vertical. It's no change in the horizontal at all. What it will do is it will check some conditions for the mob and see whether or not the mob can spawn. If it can, then it will spawn. If it doesn't, then it won't. But regardless of whether it's successful or not, when it tries to go on to the next spawning attempt for this pack, it won't look at this initial block. Instead, it will look at this last block that was chosen, this random block. So it will start from here instead of there. And once again, it's an 11 by 11 square. So, it could be right here or here, but let's just say it's over here. Now, it will do the same check to see if it can spawn. Whether or not it's successful or not, it will go on to the next spawn attempt, and at this point, instead of using that block, it will use this one. And this repeats for as many spawn attempts as you have. Since you have 4, it will go to 4, and then it will go on to the next pack. And when it goes on to the next pack, it doesn't look at this last attempt. Instead, it will go back to this initial block. So for every pack, it always starts by choosing 11 by 11 centered on the initial block. And it moves based on where the spawn attempts are after that. It just jumps around. But basically, that's how it works. Alright, all of this stuff about, choosing mob packs and 11 by 11 squares and stuff like that was probably all really confusing. So I'm going to give you some examples now that I think will help clear all of that up. Okay, for these examples, I'm going to sort of go line by line or like step by step through how the code will execute. So it might be a little funny sounding, but hopefully it will explain everything clearly. Okay, so let's say for our first example, we're trying to spawn hostile mobs. So we choose a random block within the chunk and check its material type. Let's say that it's air, so it's good for spawning hostile mobs. Alright, so the next thing it does, it chooses a random block within that 11 by 11 square centered on our initial block. Now, after it chooses this random block, it will check some conditions based on the creature type, but don't worry about those now. Let's just say that they pass. So it passes, and then it goes on to the next step, which is to figure out what type of mob to spawn. So since it's the first mob spawning attempt of the pack, it hasn't chosen a mob yet. So what it will do is it will check the biome of the chosen block, and it will ask the biome for a random mob type. And if it doesn't get a random mob type, it will choose another block, but this isn't an issue because all of the biomes in the game have at least one valid mob type. Anyway, so let's say that it picks Creeper as the mob type. So now it will see if the chosen block is valid for this guy to spawn. All of this is dependent on specifics for the individual mob, but let's say that it passes, and so we'll increase the counter for the successful spawns for this chunk by 1. Alright, so now we check the limit for the mob and compare it to the successful spawns, and we see that it's below the limit. So we'll increase the counter for spawn attempts for this mob pack, and then we'll do this loop again. So we'll choose another block nearby the previously selected block, and since we already know the mob type, we'll skip getting a type and just go on to check if it can spawn. Let's say that it spawned successfully, so once again we'll increase our counters and keep going. Alright, now to speed things up, let's jump ahead 2 more times and say that our third attempt was successful, and then we just finished our 4th attempt successfully. So we'll check the counter against the maximum number of mobs, and now we see that it's reached the limit. So in this case, it's all that we can do for this chunk. All of the values get reset, and we go on to the next chunk and run the algorithm again for that one. Okay, so now for our second example. Let's rewind back to our 4th attempt, and instead of succeeding, let's say it fails. So instead of creating a mob, we don't, so we don't increase the mob counter, and yet we still increase the mob attempt counter and continue on through the code. But this time, when we get to the start of the loop, we'll see that we've reached the limit for the mob attempts for this pack. So now, instead of making a 5th attempt, we'll stop trying to spawn mobs for this pack, and we'll increase our mob pack count by 1. Then we'll reset the mob attempt counter, reset the current mob type, set the location back to our initial block, and the only things here that don't get reset are the number of mobs that we've spawned so far for the chunk, and the number of pack attempts that we've made. Okay, now we'll try to spawn some mobs again, starting with choosing a random block and getting a new mob type. So we start with the initial block. That's the initial block that was chosen from the top, the chunk. Choose a random block within an 11 by 11 there, and then choose a new mob type based on the biome from that randomly chosen block. Anyway, so it's random. It could be the same mob, it could be creepers again, or it could be different skeletons, something like that. Anyway, you might be able to see where it's going from here. So there are basically 2 or 3 outcomes now. So we could spawn another mob here, and that would be our 4th mob. So we'd end the spawning loop for the chunk and go on to the next chunk. Or we could end up going through all of our spawn attempts for this 2nd pack and go into the 3rd pack and then end the spawning loop by spawning a 4th mob for the chunk there. Or we could go all the way through all of the attempts in the 2nd pack and the 3rd pack and move on to the next chunk without reaching the 4 mob spawning limit. And so that's how it would work in most cases, but there are actually some exceptions. The exceptions are wolves and ghasts, and they're exceptions because unlike the other mobs which have a limit of 4, you can only spawn 4 creepers per chunk, or 4 skeletons per chunk, or whatever. These have a limit of 8 for wolves and 1 for ghasts. And these are the only mobs that I found looking through the code that have a different limit. But if you happen to know of any others, let me know. Anyway, let me give you an example for wolves. So let's say that we've already spawned 3 mobs. Let's say they're pigs. And then we go on to another pack. If the pack that we spawn now happens to be wolves, we can spawn up to 4 more wolves. And the limit for the mob type, it's only checked if a spawn succeeds. So if we have another pack attempt after spawning these 4 wolves, we can actually get an 8th mob to spawn, and it doesn't even have to be a wolf. So we could have like 3 pigs and 4 wolves and then a cow. Basically the way it would work is because it's looking at the 8 from the wolves rather than the 4 from the pigs, we get more mobs spawning than we would if we just had pigs alone or cows alone or whatever. Okay, now in the case of ghasts, it's sort of the other way around. Say our first pack is a ghast, we'll get a ghast, and then that's it. All we get is a ghast. But then let's say that our first pack instead of ghasts is pig zombies. Let's say that we get 2 pig zombies to spawn, and then we go onto the 2nd pack. So now our 2nd pack, let's say, is a ghast. If it happens to successfully spawn a ghast, then it will look at the counter, and it will see that it's more than the limit for ghasts, which is only 1, and then it will end the spawning here and go on to the next chunk. So basically, even though our pig zombies have a limit of 4, because we successfully spawned a ghast which has a limit of 1, that's all the algorithm can do for the chunk, because it saw that we've already spawned 3 for this chunk. But of course, you can look at it the other way around and say that, hey, we spawned a ghast and we spawned 2 pig zombies, so we got more than just one mob for the chunk. Anyway, I hope that clears up any confusion about these exceptions and how the mob limits work and how the mob packs and individual mob spawning attempts for the chunks work. So let's go on to the next part. In this part, I'll be going into more detail on how the biomes actually randomly pick mobs to spawn. And the best analogy that I can think of to describe this is if you can imagine a pie graph. On a pie graph, you've got different sections of varying sizes. Now, if you randomly pick points on the pie graph, what you'll see is the slices of the pie graph that have the greater areas have the greater chances of being chosen. And the biomes basically work the same way. Each biome in the game has a list, and the mobs on this list are assigned a number. The number, which we'll call the weight, tells us how likely the mob is to be chosen. So the mobs with a greater number, a greater weight, have a greater probability of being chosen. Now let's talk about how this actually looks in the game. Let's start with the land animals. So land animals will spawn in almost every biome except for a few exceptions. They won't spawn in deserts, rivers, beaches, or oceans, and what will happen here is basically it will look at these biomes and say, hey, there's nothing on the list, so let's choose another block, and it will keep moving away until it finds a block that's in another biome. But anyway, let's talk about the biomes that do spawn mobs. Let's start with plains, swamps, ice plains, and extreme hills. In these 4 biomes, we've got 4 possible animals that can spawn. Those are sheep, pigs, chickens, and cows, and they have weights of 12, 10, 10, and 8, respectively. Basically, sheep have the greatest chance and cows have the smallest chance. Now, there's some other differences in other biomes, so let's talk about those. Let's talk about jungles first. In jungles, we have the same 4 mobs, but they have weights of 12, 10, 20, and 8. Basically, now chickens have the greatest chance of being spawned in jungles. Now, there's some other biomes as well. Let's talk about taiga and forests. In taiga and forests, we add wolves to the ratio. In taigas, we have 12, 10, 10, 8, 8, where wolves are added with 8. And in forests, we have 12, 10, 10, 8, 5, where wolves have a weight of 5. Basically, both taiga and forests are allowed to spawn wolves, but taiga are slightly more likely to spawn them than forests are. Anyway, there's one more biome left to talk about in the overworld, and that's Mushroom Islands. On Mushroom Islands, only mushrooms are allowed to spawn. And since they're the only mob that's allowed to spawn, the weight doesn't actually matter. Basically, it's as if our pie graph were just one color, or one section. Anyway, that's all for land animals. Let's go ahead and talk about monsters. So, monsters will spawn anywhere in the overworld except for on Mushroom Islands where they're not allowed to spawn. So let's talk about the biomes other than Mushroom Islands. On all of the biomes other than Mushroom Islands, we've got 6 monsters. Those are creepers, skeletons, spiders, zombies, slimes, and endermen. There's one exception to this, and that's in jungles where ocelots are added, but I'll get to that in a moment. So let's talk about all the other biomes other than jungles first. So in these, we have weights of 10, 10, 10, 10, 10, and 1. And remember, that's for creepers, skeletons, spiders, zombies, slimes, and endermen. Basically, endermen have the lowest chance of being picked, and the rest have about the same. And that's how it works for almost all the biomes. Then we have jungles. In jungles, we have the same weights for the monsters, but we add ocelots with a weight of 2. Basically, all the monsters have a lower chance of spawning in jungles in favor of ocelots. And that's how that works. Now let's talk about the nether monsters. So in the nether, there's only one real biome. There's another section of the nether in nether fortresses that actually replaces the list for the nether biome, the hell biome. But anyway, let's talk about the hell biome first. So the hell biome has 3 monsters, and those are pig zombies, ghasts, and magma cubes. And they have weights of 100, 50, and 1. Basically, pig zombies are very common, magma cubes are very rare. Magma cubes only have a 1 out of 150 chance of being picked to spawn. Now, on nether fortresses, we don't have ghasts. Instead, we have blazes, and we have blazes, pig zombies, and magma cubes here. And those have weights of 10, 10, and 3. So now, if you basically want to spawn magma cubes, what you will need to do is go to a nether fortress. But anyway, That's all there is for the monsters. Of course, there's also the end, but since only Endermans can spawn there, that one really doesn't matter. Let's go on to the next part. Okay, in this next part, I want to talk about how the random blocks from these 11 by 11 squares are actually chosen. So it's not a uniform distribution. It's not the blocks don't have the same probability of being chosen. It's actually very concentrated in the center of this square. The reason for that is because the block is chosen by choosing a random number 0 through 5 and then subtracting another random number 0 through 5. And it does this for both the x and the z directions. The y direction is the same, so that one doesn't matter. But anyway, the result is a lot of chances for the blocks to be chosen within closer to the center area. So using this information, we can actually come up with a probability distribution for where the mobs will spawn from these packs. And they'll spawn anywhere within this area, which is a 41 by 41 square. The reason for that, of course, is, let's say this is our initial block. Since there are 4 spawn attempts, we can have 1, 2, 3, 4 as far out as this. But anyway, we can actually get probability distributions for each set, so each attempt we can see what the probability is, and we can also see what the overall probability distribution, what the mob spawn distribution is. So let me give you some overlays and show you what that actually looks like. So here's for just the 11 by 11. Here's for the second attempt. Here's for the third attempt and the fourth attempt. And then if we sort of combine them, I guess you could say, say we look at all 4 attempts, this is the weighted sum of those 4 attempts, what it would look like. And the result is, if we have mobs starting at this initial block, then we'll have 74.9% of them occurring within 5 blocks of the initial block, and then 98.2 within 10 blocks of the initial block. So hardly any of them outside of these first 2 rings. Anyway, so now we have a good idea of how spawning locations are chosen. Let's go and talk about more specific details on the spawning requirements for mobs. Okay, the first requirement that we need to take a look at is based on the creature's material type. So if you remember when I said that a block is selected for mob spawning, we'll check some conditions based on the creature type. That's what I'll actually be talking about here. But before I get into specific details on it, I want to define something. And what I'm going to define is what's called in the game code a normal cube. So normal cubes are blocks in the game that fit 2 conditions. The first condition is that the block has to be opaque, and the second condition is that the block has to be rendered as a cube. So things like wool or grass blocks or dirt or stone, all of these fit into the normal cube category. Things like glass, however, which even though they're rendered as cubes are not opaque, they're transparent, do not fit into the normal cube category. Other blocks that don't fit into the normal cube category include things like stairs and slabs and signs and torches, and the reason for this is because they're not rendered as cubes. Also things like air and water don't fit into normal cube category either. So that's normal cubes, and those are related to the conditions for these material types. Let's talk about the conditions for water creatures first. There are 2 conditions for water creatures. The first condition is that the selected block has to contain water. It can contain any amount of water in any type of water as long as it contains some water. So it could be coming down from the top or flowing in from the side, or it could be a source block like this, or it could even be an eighth of a block from a source block 8 blocks away. As long as there's some water, it's fine and it passes that condition. The second condition is that the block above the selected block, so if we have this water block as our selected block, then this would be the block above it. The second condition is that that block above has to be a not normal block, or not normal cube, which means something like wool would prevent mob spawning, but something like glass would allow it, and signs also, or torches, would allow it, and of course air and water would allow it. Now, for air, the conditions are a little different. There are 3 conditions, and they're based on the selected block, the block above, and the block below. Let's start with the condition for the selected block. The condition for the selected block isn't that the selected block has to be air, but rather that it has to be a block that is not a normal cube. Now, you might be a little confused here because I just said that glass blocks were not normal cubes, but you should know that mobs definitely can't spawn inside of glass blocks. That's true, and there's a reason for that. Even though technically they can pass this check if there's a glass block here, there are conditions later on that prevent that from happening. So let's ignore that for now and just know that because this block has to be not a normal cube, that means that things like signs and torches and grass and air and water are all fine. Now, what about the block above? Well, it's the same as for water. The block above just has to be a block that is not a normal cube. So things like glass would work, things like wool would not work, things like signs would work, and things like torches would work. So that's all for the block above. Now what about the block below? This is actually a set of conditions. So the first 2 conditions are that the block has to be a normal cube that is not bedrock. This means it can be any normal cube in the game: stone, dirt, sand, wool, except for bedrock. If it's bedrock, mobs will not be allowed to spawn on it. Now, there are 2 additional exceptions to this. It can be upside down stairs or topside slabs. These are exceptions because upside down stairs and topside slabs are not normal cubes. The reason for this is because of 1.3, where they added mob spawning on these surfaces. So that's just a little difference from 1.2.5 and 1.3. But that's all there is to the requirements for air and water types. So let's go on to some more requirements. These next requirements apply to pretty much any mob in the game if it uses the spawning algorithm. So hostile mobs, peaceful mobs, air mobs, and water mobs, they all have to check these requirements. And the first 2 requirements that I want to talk about are distance requirements. No mob can spawn within 24 meters of any player, and no mob can spawn within 24 meters of the world spawn. So basically the check just sees wherever the selected box is, what is the distance to the nearest player, and what is the distance to the world spawn, and if it's less than 24 in either of those cases, don't spawn. Now, this is 24 meters, not 24 blocks, so it's a sphere in all directions, so keep that in mind. Now there's a third requirement that applies to pretty much all mobs, and that's the bounding box check. So what is this bounding box? A bounding box is basically the smallest box that you can fit around the mobile entity's model. And a mobile entity is just a mob or a player. And for example, if we want to talk about the bounding box of this Enderman, well, we know an Enderman fits in a 1x3 block area, but that's not really his bounding box size. As you can see, he's shorter than 3 blocks. He's more like 2.5, and then he's, not quite 1x1. He's a little narrower than that. So his bounding box would be just under 3 blocks tall and just under 1x1 wide. And that's the bounding box for an Enderman. For a slime, it would be pretty much exactly the shape of the slime's model since they're a cube, and then for something like a spider, it wouldn't quite be 1 block high, and it would be a 2x2 wide. But what do we actually use this bounding box check for, and how does it actually work? Well, the bounding box check is basically a check to see if there's any stuff that we don't want inside of the mob's bounding box. Now, by stuff we don't want, we mean other living entities, which are mobs and players, or solid blocks, and then in the case of air mobs, any liquids. For water mobs, liquids are fine, so it can be in water. But in the case of something like this Enderman, or this creeper for example, if we've got other mobs in the way, he's not going to spawn. If we've got water in the way of this pig, he won't spawn. Things like that. And this goes back to what I talked about over there. Remember I said the only requirement is that this block is not a normal block? Well, this is resolved with the bounding box check. Because if we don't have a normal block here, like glass is not a normal block, remember? And we do the bounding box check, as you can see, this creeper, his bounding box would be inside of the glass, which means he wouldn't spawn. So, basically, that resolves the issue with the glass that we had earlier. Now, this also explains why we can spawn creepers in a 2 high area, but not in a 1 high area, but why we can spawn spiders in a 1 high area, and also why Endermen need 3 high space to spawn. The bounding box check explains all of those things. Alright, now let's talk about actual mob-specific requirements. In this section I'll be talking about peaceful mob spawning. Specifically I'll be talking about creatures, which are the land animals. I'll start by talking about the ones that are not ocelots, because ocelots are a bit weird. So pigs, mushrooms, cows, sheep, chickens, and wolves. These guys have only 2 requirements. The first is the block that's selected has to have a light level of 9 or greater. So if it's too dark, these guys won't be allowed to spawn. The second requirement is that the block below the selected block has to be grass. So they won't spawn on anything like dirt or stone. It has to be grass for them to spawn. What this means is, if you want these guys to spawn, all you've got to do is light up an area of grass. Of course, you won't necessarily get them to spawn because the cutoff limit is so low, it's only 15. If there are already 15 in the world, they won't even attempt to spawn them. Now, this also means that mushrooms don't spawn on mushroom islands. And the reason for that is because there's no grass. All of the mushrooms that you see on mushroom islands were created there with the terrain generation. If you actually want them to spawn there, you have to bring grass to the island. This is also why you might see mushrooms growing or spawning outside of mushroom islands, because there's grass there. So you see them pop up like on the sides of the beaches and stuff like that. Anyway, that's all for these guys. Let's talk about ocelots now. So I said these guys were a bit weird, and there are a few reasons for that. First of all, unlike these guys, they don't have a light level requirement, so they can spawn at any light level, at night or day, doesn't matter. Second of all, they can also spawn on leaves, so they spawn on both grass and leaves, and they don't have to be jungle leaves, they can be any type of leaves. This is why you might see ocelots running around in the treetops of your jungles. The third thing is, they have a height level requirement. They can only spawn in heights above 62. That means the height of the selected block has to be 63 or greater. Now, there's one more thing that makes ocelots really weird, and that is they don't spawn with the rest of the creatures. They spawn with the monsters instead. Now there's a reason for this. It's because the number of creatures, the cutoff for creatures is so low. So instead, ocelots will spawn with monsters, so you can still get ocelots to spawn even when you have a lot of passive mobs around. And that's the reason for that. Alright, now let's talk about hostile mob spawning. I almost forgot about squids, so let me get to them before I go to hostile mobs. They only have one specific requirement, and that's the height of the selected block. The selected block for their spawning has to be between height 46 and height 62. So, if you need to spawn squid, make sure that they're between those heights, and you can get squid to spawn. Alright, so now onto hostile mob spawning. So let's begin the explanation of hostile mob spawning with the overworld mobs. We'll talk about slimes later because they're a little different, and talk about zombies, creepers, skeletons, and spiders and endermen now. These 5 guys have 2 checks that determine whether or not they can spawn, and those are related to light level. The first of these checks is related to the skylight exposure level. I'll just call it the skylight level. And then the other check is related to the overall block light level, which I'll just call the overall light level. So this overall light level is the BL value that you see in the debug screen. As I get closer to a light source, it increases. As I get further away, it decreases. And this is affected by whether it's day or night, and of course other nearby light sources. The skylight level is this SL value, which as you can see right now is 15. It's not affected by nearby light sources, and it's not affected by whether it's night or day. The only thing that it's affected by is the exposure to the sky. If, in case you're wondering, the RL value here is the higher of either the BL or the SL value, and it's used for things that don't care whether it's skylight or overall light. They just care what the value is and which is higher. But anyway, so we can change this skylight level by putting blocks of cover. If we have one block of cover, it will go down 1. If we have 2 blocks of cover like this, so if we have 2 in all directions, it will go down by 2. And so on and so on. We can continue this all the way down to 0 if we want, like in a cave or under a big roof. But for now, let's just talk about how it affects spawning. So this value affects spawning by effectively decreasing the chance of successful spawns. If this value is greater than a number 0 through 31, a random number 0 through 31, then the spawn attempt will simply fail. Now, that means that as skylight values are higher, there's more of a chance for it to fail, and as skylight levels are lower, there's less of a chance for it to fail. So if it's 15, you've got 15 compared to a random number 0 through 31. That's a range of 32 numbers. That means from 0 through 14, 15 of those numbers, there's a chance for it to fail. So 15 out of 32 times, the spawn attempt will fail. That's nearly half the time when you've got complete exposure to the sky like this. And of course, if you cover it up and go down to like 1, then it's only 1 is only greater than 0. So 0, that's only 1 out of 32 chances for it to fail. So it's much, much smaller as you get more cover. And of course, when you have a skylight level of 0, since 0 can't be greater than any of the numbers 0 through 32, it will always pass if it's completely covered. But just because it will pass this skylight check doesn't mean that it will pass the mob spawning check, because there's the overall light level check. And I've got this setup over here to explain that more clearly. So before I begin with this setup, let me explain what it is. I've got a torch here, and the gray wool here shows where mobs cannot spawn at all. The dark gray shows where they have a chance of spawning, and the black is where they will always spawn. So this torch is on the level that's above this gray wool, and the level above this gray wool has the whatever the BL value plus 1. So I'm looking right now at this block. It has a BL value of 7. It's 6 because it's the block where my eye level is, which is right here. So when I talk about the light level, I'm talking about this level. So there's 7 right here. Now, the way this affects mob spawning is it does another comparison, but this time it's seeing, is the block light level, the BL value, less than or equal to a random number 0 through 7. So basically what this means is if we have 7 here, for example, and we do a random check to see if this number 7 is less than or equal to a random number 0 through 7, the only time this can succeed is if that random number happens to be 7. And if it happens to succeed, then it will actually spawn the monster. But if it fails, then it won't. So as you can see, we've got 0 through 6, which are not going to succeed the check. That's 7 out of 8 times that a light level of 7 will fail to spawn. And of course, this decreases all the way down to 1 out of 8 times when we're at light level BL1. And then when we get to BL0, since 0 is less than or equal to all of the numbers 0 through 7, they will always spawn if they get to that point. So that's how the light level checks work for mobs. As you get closer to light sources, you have a reduced chance of spawning, and when you get to a block level of 8, since 8 is always going to be greater than any of the numbers, random numbers 0 through 7, mobs aren't allowed to spawn. And anywhere lower than that, they have an increasing chance to spawn all the way down to block light level 0, where they will spawn 100% of the time. And this is just a diagram or a figure to show what a torch looks like, or the range of a torch, where this gray wool, of course, is where they cannot, the light gray is where they have a chance, and the black is where they might. And here's a redstone torch by comparison. They have a chance to spawn in all of this area, and yeah, there's nothing that a redstone torch can't block out. Anyway, now that I've talked about those mobs, which seem to have despawned here, I'll talk about slimes. As I said, slimes are a little different. They don't have a light level check, so they can spawn in any light level. We could put a torch right next to them and be able to spawn just fine. But they do have some other conditions. The first of which is the height of the block that's selected has to be less than 40, which means it's 39 or lower. In addition to that, they have to pass a 1 out of 10 random check, which means 1 out of 10 times will it pass and they'll be allowed to spawn. The other times, they'll just completely fail to spawn and won't be allowed. So 9 out of 10 times, even if a slime is selected to spawn, it won't. And the last part is, it has to be in a special chunk that's determined by the seed of the map. And that's all there really is to slimes. They'll spawn pretty much anywhere as long as it meets those conditions. Okay, now let's go on to the nether mobs. For the nether mobs, let's start with pig zombies and magma cubes because they don't have any special requirements. Basically, these guys can spawn anywhere in the nether, and there's no light level check, so they can spawn in any light level. And the only thing that could stop them from spawning is if they fail a bounding box check. Basically, if there's something intruding within the bounding blocks of the model. Other than that, they'll spawn pretty much anytime, any place in the nether. Now for ghasts, they'll spawn pretty much anywhere in the nether except for within a 10 tall and 5 across rectangle that's located around the nether fortresses, around the walkways of the nether fortresses. Also, they have to pass a 1 out of 20 random check. Basically, 1 out of every 20 times will they actually be able to spawn. Other than that, no other requirements. They can spawn anywhere else other than those areas around the nether fortresses, and they can spawn in any light level. Now for blazes. Blazes are only allowed to spawn within this range of the nether fortresses. So you have a walkway in a nether fortress like this, and it can be inside and covered by a roof, or it can be uncovered like this, it doesn't matter. But basically, there's this range that's 10 tall and 5 across, that's 4 below the walkway and 5 above it, in which blazes can spawn. And that's all there is to it. They don't have to pass a light level check either, so that's all of the nether mobs. Alright, now on to the next part. Okay, in this part I'll be talking about mob despawning. The mobs that are allowed to despawn are hostile mobs, angry wolves, squid, and untamed ocelots. And the way this works is no mob will despawn within 32 meters of a player, but once they move outside of this 32 meter range, they'll start to age. And they'll age for 30 seconds. After 30 seconds, then they'll have a chance of despawning each tick. And this chance is 1 out of 800. So 1 out of 800 chance per tick. Since a tick is 1/20th of a second, this works out to be about 40 seconds after it has reached an age of 30 seconds to despawn. So as a result, once a mob moves outside of this 32 meter radius, you should expect to see them despawn after about 1 minute and 10 seconds. Now, if a mob continues to move further and further away from a player, so far that it moves 128 meters from a player, then it will instantly die and despawn on the next tick. And that's how mob despawning works. Okay, now we'll go on to the next part and show you what we've learned in this video. In this video, we learned that the mob spawning algorithm will attempt to spawn hostile mobs in every tick, but will only spawn them on difficulties greater than peaceful. We learned that peaceful mobs will only spawn once every 20 seconds, but can spawn in any difficulty. We learned that mobs will attempt to spawn within chunks that are in a 15 by 15 square of chunks centered on each player. We learned that mobs will not spawn if the current number of mobs that is loaded by the game for a particular creature type is higher than a calculated cutoff limit. But we learned that this calculated cutoff limit is only checked at the beginning of the spawning loop, so it's actually possible to spawn more mobs than this limit. We learned that in single player these limits are 79 hostile mobs, 16 animals, and 5 water mobs. We learned that in multiplayer these limits can be higher depending on the number of players and their distances from each other. We learned that the spawning loop will iterate through all of the spawning chunks once for each creature type. We learned that an initial block is randomly selected in each of these chunks from all of the blocks in the chunk from the bottom of the map to the top of the highest segment in the chunk that contains a non-air block. We learned that a segment is a 16 block tall division of the chunk. We learned that the top of the highest segment in the chunk that contains a non-air block can be easily checked by looking at the LC value in the debug screen. We learned that for all mobs other than squid, this initially chosen block has to be an air block, and we learned that for squid it has to be a water block. We learned that mobs can spawn as far as 20 blocks in any horizontal direction from the initially chosen block in each chunk, but 98% of them will spawn within 10 blocks of this initially chosen block. We learned that there must be no other mob, no solid block, nor any liquid within the bounding blocks of a mob for it to be placed in the world, except in the cases of squid, which will allow liquid into the bounding blocks. We learned that mobs cannot spawn within 24 blocks of any player, and that mobs cannot spawn within 24 blocks of the world spawn. We learned that the mob type is determined by the biome. We learned that mobs spawn in packs, and that each pack can make up to 4 attempts to spawn mobs, and each chunk can make up to 3 packs. But we also learned that there's a limit of up to 4 successful mob spawns per chunk, with the exception of a few mobs. And finally, we learned that some mob types can despawn. The mob types that have a chance of despawning will do so between 32 meters and 128 meters away from any player, and will despawn instantly beyond 128 meters of any player. So, that's all for this video. I hope you found it informative. Like I said before, if you find anything that doesn't seem right, let me know and I'll take another look at the code and I'll annotate those areas if I'm wrong. But anyway, I hope you enjoyed. I hope this video is to your liking. If you have any comments or suggestions, please let me know in the comments. And thanks for watching.